All right. Hello, everyone, and welcome to the Moldex 3D webinar series. My name is April Brown, the applications engineer from the Moldex 3D North American office in Farmington Hills, Michigan. And today we're going to be talking about advanced simulation techniques for predicting and mitigating stress marks in the Moldex 3D studio. All right, so let's get started. Today I'll have an introduction to shear stress, break down the benefits of using a hot runner system, using pin movement to help mitigate stress marks, and then show you some case studies that use different approaches and to eliminate stress. So stress is a common flaw in injection molding process, um, typically appearing as a visible discoloration or whitening on the surface of the part. And this issue arises from the release of internal stresses within the material. So whether it's coming from a gate, possibly a variance in part thickness, or coming from an embossed feature. Some other forms that it can appear as well um, is what we sometimes call a hesitation line or even tiger striping. So, understanding shear stress. So, it's a measurement of the tension created by the molecules caused by shear flow. So, in the equation, the viscosity is it's the viscosity times the shear rate. So the higher the viscosity, the more shear stress can develop. The same thing for shear rate, which is a gradient of the velocity of flow. So the higher the velocity, or let's say a fast fill time, the higher the shear stress can occur as well. And because we're dealing with a non-Newtonian fluid, the shear flow will change the viscosity of the melt. If we think of water, which is Newtonian fluid, increasing the velocity, its viscosity does not change. But for plastic, as you increase the velocity or shear rate of the viscosity decreases. Remember, the viscosity is the resistance to flow. So the higher the viscosity, the more resistance, and the lower viscosity, the less resistance.